I'm Rasika Ramakrishna and let's continue with the chapter on probability. Exercise 15.1, question number 5. An organization selected 2,400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information gathered is listed below in the table. Alright, so here the leftmost column we have the income per month. So it's given in a range. So less than 7,000, 7,000 to 10,000 and so on. And the second, third, fourth and fifth column talk about the number of vehicles owned by the family. So suppose a family is chosen at random. Find the probability that the family chosen is 1. Earning 10,000 to 13,000 per month and owning exactly 2 vehicles. 2. Earning 16,000 or more per month and owning exactly 1 vehicle. 3. Earning less than 7,000 per month and does not own any vehicle. 4. Earning 13,000 to 16,000 per month and owning more than 2 vehicles. 5. Not owning more than 1 vehicle. Alright, so I know that these subdivisions might seem like a handful at the moment, but once we get to it, it will be pretty easy. Let's see how that happens. Okay, so before we go into that, we know that we've got to compute the empirical probability. So it's always good practice to identify the experiment, trial and event. So the experiment in this case is going to be collecting data from families, and the trial. Each trial is going to correspond to each family the data is collected from. So the total number of trials is going to be the total number of families from whom data is collected. So in this case, that's going to be 2,400. Alright. Event. So since we have 5 different subdivisions, we are going to have different events for different subdivisions, and we will thus see what the event is when we encounter the subdivision. Let's quickly recall that the probability of an event occurring is given by the number of trials in which the event has occurred divided by the total number of trials. This is the formulation of empirical probability. Alright. So the first subdivision asks you to find the probability of earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. Alright, so here let's quickly see that the event is earning 10,000 to 13,000 and owning exactly 2 vehicles. Alright, so now that we know the event, we can see that the probability is given by the number of families earning 10 to 13k and owning 2 vehicles divided by the total number of families. So the numerator is going to be the number of trials in which the event has occurred, and the denominator is the total number of families, which is nothing but the total number of trials. Alright, so let's have a quick look at the table given in the question. We can see that 29 people earn from 10,000 to 13,000 and own exactly 2 vehicles. So let's go ahead and compute the probability. So the total number of families we know is 2,400, and we just saw that the number of families earning from 10 to 13k and owning 2 vehicles is 29. Therefore, the probability of earning from 10 to 13k and owning 2 vehicles is 29 by 2,400. Alright. So let's go to subdivision 2. So subdivision 2 asks you to find the probability of earning rupees 16,000 or more per month and owning exactly 1 vehicle. So this is exactly going to be the event. The event is earning 16,000 or more per month and owning exactly 1 vehicle. Alright, so you know that this probability is given by the number of families earning 16k or more per month and owning 1 vehicle, which is nothing but the number of trials in which the event has occurred, divided by the total number of trials, which in this case is going to be the total number of families. Alright, so let's look at the table given in the question. We can see that the last row talks about 16,000 or more per month, and we have to find the number of people who earn this much and own exactly 1 vehicle. So that is nothing but 579. Okay, so now that we have this, let's go ahead and compute the probability. So the total number of families you can see is 2,400, and the number of families earning 16k or more and owning 1 vehicle is 579. We just saw that. Therefore, the probability of earning 16k or more and owning 1 vehicle is given by 579 by 2,400. Alright, so in subdivision 3, you are asked to find the probability of earning less than rupees 7,000 per month and not owning any vehicle. Okay, so here the event is going to be earning less than 7,000 per month and not owning any vehicle. Alright, so you know that the probability is given by the number of families earning less than rupees 7,000 per month and not owning any vehicle. That is the number of trials in which the event has occurred divided by the total number of trials, which is nothing but the total number of families. Alright, so let's have a quick look at the table given in the question, and we can see that the very first row talks about people who earn less than 7,000, and corresponding to the column 0, we can see there are 10 people who earn less than 7,000 and own no vehicles. So now that we have this information, we can go ahead and compute the probability. So you know that the total number of families is 2,400 and the number of families earning less than 7,000 and not owning any vehicle is 10. We just saw that. Therefore, the probability of earning less than 7,000 and not owning any vehicle is given by 10 by 2,400, which upon simplification is 1 by 24. So we've got to find the probability of earning 13 to 16k per month and owning more than 2 vehicles in subdivision 4. So we can see that the event here is earning 13 to 16k per month and owning more than 2 vehicles. So you know that the probability in this case is given by the number of families earning 13 to 16k and owning more than 2 vehicles, that is the number of trials in which the event has occurred, divided by the total number of trials, which is nothing but the total number of families. Alright, so let's have a quick look at the table, and we can see that the number of people who are earning from 13 to 16k and owning more than 2 vehicles are 25. Okay, so let's go ahead and compute the probability. So the total number of families is 2,400 and the number of families earning from 13 to 16k and owning more than 2 vehicles is 25. So therefore the probability of earning from 13 to 16k and owning more than 2 vehicles is 25 by 2,400, which is nothing but 1 by 96. So subdivision 5 is a slightly tricky one. Let's see what it says. We are asked to find the probability of owning not more than 1 vehicle. Here the event is going to be owning not more than 1 vehicle. Alright, so you know that the probability in this case is given by the number of families not owning more than 1 vehicle, that is the number of trials in which the event has occurred divided by the total number of trials, which is nothing but the total number of families. Alright, so here is the table from the question. So since we are given no income group, how do we go about this? So let's first see that not owning more than 1 vehicle implies you can either own no vehicles or you can own 1 vehicle. So we have to add up all the families who own 0 vehicles and who own 1 vehicle. So that's going to be adding up this column and this column. So please do that, and after you do that you will see that the total number of families, you know, obviously 2,400, and the number of families not owning more than 1 vehicle, which we just saw, is sum of families owning 0 vehicles plus sum of families owning 1 vehicle, which is nothing but 10 plus 160 plus 0 plus 305 plus 1 plus 153 plus 2 plus 469 plus 1 plus 579, which is nothing but 2062. Therefore, the probability of not owning more than 1 vehicle is 2062 divided by 2,400, which is nothing but 1031 divided by 1,200.